Aloha and welcome to our conditions for speciation to occur video. Today we are going to talk about how speciation occurs. We're also going to compare three different theories on the rate of speciation. So we'll talk about punctuated equilibrium and the coordinated stasis theory as well as what it was before. Okay, if you can recall from the last video, we talked a little bit about speciation. And what I want to do is I want to talk to you a little bit more about that. Now, speciation occurs when we have a population. So we're always going to have our original population. And then what we notice is there's some kind of a change in the selective pressures. So whether it's natural selection or whether it's behavioral, but somehow or another there's going to be a change in the selective pressure on the different alleles or on the different variants, and that's what's going to cause speciation to occur. So with allopatric, we talked about this geographic barrier. If we have one population, it gets split in two by like a mountain range or something, then what we notice is over time we have two distinctly different populations. Parapatric here is going to be where it's just partially separated, and we can see some of the original population here, but then we'll see it split into our two new populations as well. Sympatric is this genetic polymorphism, and that would be more behavioral, where we might have the population splitting and saying we want to have this, and this trait's more important, and some will breed for that trait, and others, members of the species, will not. So it tends to be more behavioral. So we can see that speciation is when we have a difference in the selective pressure on an allele, and then that'll lead to that speciation. Okay, and generally I'm saying an allele, but generally it's going to be a little bit more. It'll be like a bunch of them together and cause some kind of a variation or difference. So one of the big debates is this rate of speciation. How fast does it happen? When does it happen? And that kind of things are those questions. Now, our older theories of evolution tend to fall under this phyletic gradualism. And what that means is that species change over time, but it's long periods of time. So we start off with an ancestral species, and then all of a sudden there's a little shift that some might want to be darker and some might want to be lighter. And over time, we'll see some intermediate species, and then finally we end up with our two modern species where they're going to be distinctly different colored and different species. So it's just a slow, gradual change. Okay, and that's what phyletic gradualism is. Then we can have punctuated equilibrium, and punctuated equilibrium says that you have these long periods of time with nothing going on, and then you have a rapid evolutionary change. So right here you'd see a rapid evolutionary change. Right here you'd see a rapid evolutionary change. But this species here might still be the same species. It's just gone through periods of like stasis, no changing. Stasis kind of means that it's just stationary. It's not having any decision to change. Life is good. It's happy. Okay, but if you presented an opportunity to exploit a new niche or something, that's when you see rapid evolution occurring. And then finally, we have this coordinated stasis idea. And that says that many new species at once. And that's typical after mass extinctions. So what we're talking about is like right here, you could have had something huge. So let's just take the dinosaurs were evolving. They evolved into their species. They're going to be replaced by new species over time, but they were kind of happy there. And then this big asteroid came and plowed into the Earth. And that caused a huge global change, a global shift in the environment. And that was causing mass extinctions. And then after that, because all of those niches that dinosaurs used to fill were open, that allowed for this rapid bloom of many new species coming in because you had animals coming in and starting to exploit new niches. So punctuated equilibrium and coordinated stasis kind of sound the same. Punctuated equilibrium is more tied to individual species, whereas coordinated stasis say that there's a lot of species happening at the same time because you have these global mass extinctions and it causes an opening for evolution to occur. Okay, so that's it for this video. Good luck with the lessons. They'll go into a little more detail, and as always, we'll see you in the next video.